Assalamualaikum students. I am Asma and I am here with the second program of calculus of BSCS level, which is about real numbers, intervals and inequalities. But before going to today's program, let me give you a brief introduction of previous program. In our previous program, we studied history of calculus, differential calculus, integral calculus, achievements of different scientists in solving problems of calculus, and some applications of calculus. As I told you that in today's program we will study real numbers, intervals and inequalities. So after the end of this program, I hope that you would be able to know about classifications of real numbers, some basic operations on real numbers, intervals, inequalities and solution of inequalities. Dear students, first of all we will study about numbers, as numbers are the foundation of mathematics. So it is important to be familiar with the various kind of numbers and difference between them. There are basically two types of numbers which you can see on screen. Types of numbers: real numbers and imaginary numbers. What are real numbers? To study real numbers, first of all we have to study the classification of real numbers. The first classification of real number is natural number. Natural number are the most simplest number in mathematics. You can see an example of natural number on the screen. Natural numbers. As an example, we can consider capital N is equal to 1, 2, 3, 4, 5 and so on, where capital N is the notation for natural numbers. The second classification of real numbers is integer. Natural numbers form a subset of a larger class of numbers which are called integers. Integers are denoted by z. You can see an example of integers on the screen. Integers. Integer starts from 0 and then 1, 2, 3, 4 and so on. Integers can be positive and negative as well, so we can consider integers as -1, -2, -3, 4 and so on. The third classification of real number is whole numbers. If we simply add a 0 with natural numbers, so it becomes whole numbers. You can see an example of whole numbers on the screen. Whole numbers. As an example, we can consider whole numbers are equal to 0, 1, 2, 3 and so on, where we have simply attached a 0 with natural numbers. Now here comes the fourth classification of real numbers, which is rational numbers, a subset of a still larger class of numbers called rational numbers, or simply when two numbers can be written in P over Q form where Q is not equal to 0, so it's called real number. You can see examples of rational numbers on the screen. Rational numbers are basically the numbers when numbers can be written in P over Q form as I defined, and where Q should not be equal to 0. As some examples of rational numbers, we can consider 2 by 3, 7 by 5, 6 by 1, 0 by 9, 5 by 2, etc. Here rational numbers in mathematics are denoted by Q. The very last and fifth classification of natural number is irrational number. The numbers which cannot be written in P over Q form are called irrational numbers. You can see some examples of irrational numbers on the screen. Some examples are under root 3, under root 5, 1 plus under root 2, cos 19 degree, etc. In mathematics, irrational numbers are denoted by Q dash. Now, after studying all the classifications of real number, we move to the definition of real numbers. Every number which is a combination of natural number, whole number, integers, rational numbers and irrational numbers is called a real number. Or for real numbers, we can say that real numbers is equal to Q union Q dash, where Q are the rational number and Q dash are the irrational numbers. Dear students, there is one more concept in numbers, which is division by 0. In computation with real numbers, division by 0 is never allowed. To understand this concept, you can consider this slide. Division by 0. If we consider y is equal to p divided by 0, so here if p is not equal to 0, so y becomes infinity. But for the second case, that if p is equal to 0 means we have 0 in numerator as well in this expression, then y is equal to 0 divided by 0, which is an undefined form as well. So in mathematics, whenever we have 0 in denominator, both cases are infinity or undefined, which does not exist in real. Dear students, now let's move to the second type of numbers, which are complex numbers. As all of you know, that square root of a real number can never be negative. So under root minus 1 is totally an unobvious number which does not exist in real. To understand complex number, we can consider an example which is on the screen. Complex number. If we consider an example which is x square is equal to minus 1, now by taking under root on both sides, we have x is equal to under root minus 1. Here in mathematics, under root minus 1 does not exist. So we have x is equal to iota, which is a specific notation for under root minus 1. Mathematicians solve this problem and investigate this number as imaginary or complex number. Complex numbers mostly arises in the solution of quadratic equation. You can see a quadratic equation on the screen. Quadratic formula for a quadratic equation which is ax square plus bx plus c is equal to 0. We have the formula of the solution as x is equal to minus b plus minus under root b square minus 4ac divided by 2a, where a, b and c are constant and x is the variable to be solved. Here d is equal to b square minus 4ac, which is called discriminant of quadratic equation, which can be 0 or less than 0 or greater than 0. You can consider some cases when x would be a real number or a complex number, which is on the screen. For a complex number, if we consider discriminant is equal to b square minus 4ac, and if this discriminant or d is greater than 0, so x would be equal to a real number. But if d is less than 0, so x would be equal to an imaginary or complex number, because d less than 0 would make the under root value as negative, which does not exist or which results in complex number. Now students, the hierarchy of numbers can be summarized in this figure which is on the screen. For a complex number, if we consider a plus b iota, where a and b are real numbers and iota is equal to under root minus 1. Then at the second part, we have real numbers, which are the combination of irrational numbers, rational numbers, integers and natural numbers. Dear students, the second part of today's lecture is interval. First of all, we will explain some symbols and some basic terminologies which are used in intervals. The first term which is used in interval is set. You can see the definition and example of set on the screen. Set is basically the combination of well-defined distinct objects. You can see the example of natural number on the screen. For a set, if we consider capital A is equal to 1, 2, 3, 4, 5, which is the set of first 5 natural numbers. This set can be written as set builder notation as well. So here in set builder notation, the set of first 5 natural number can be written as x, such that x belongs to natural numbers and x is less than or equal to 5. After considering the definition and example of set, we move to interval. You can see the definition of interval on the screen. Interval. In calculus, sets of real numbers are called intervals. Or geometrically, an interval is like such that a less than b, where b is a larger number. You can see the example of open and closed interval on the screen. For closed interval, we would be using square brackets, and if we consider interval between a to b, that would be written as x such that x is greater than or equal to a, n less than or equal to b, means x lies between a to b, but over here a and b are included as well. For example of open interval, we would be using the notation of parenthesis. So open interval can be written as x such that x is greater than a but less than b. Over here in open interval, a and b numbers are not included, but all the numbers which are greater than a and less than b are included. As intervals can be open or closed, so interval can be finite or infinite as well. You can see the definition and example of finite and infinite intervals on the screen. Types of interval. Finite interval. Intervals of finite extent are called finite intervals. Infinite interval. Intervals of infinite extent are called infinite intervals. In this slide, you can consider some examples of finite interval and infinite intervals. Finite interval can be written as a to b in parenthesis, or a parenthesis a and b a square bracket. Or you can consider a finite interval which is starting from a square bracket but ending on a parenthesis. For infinite interval, which would be of infinite extent, we can consider a square bracket a to infinity parenthesis, where this infinity would definitely be not included or defined. For second example, we can consider minus infinity to b, where b is included as we have attached a square bracket with it. Now from the slide on the screen, you can know about set notation, geometric picture and classification of intervals. For the first example, if we consider a set notation as x such that x is greater than or equal to a and less than or equal to b. So its geometric picture would be like this, where this a and b number both are included. So its classification is as finite and closed interval. For second example, if we consider a set notation as x such that x is greater than a and less than b, so its figure would be like this, where a number and b number is not included, but all the numbers between a and b are included. Its classification would be as finite and open. For the third set notation, if we say x such that x is greater than or equal to a but less than b, its geometric picture would be like this, where a is included but b number is not included. Its classification is as finite and half open, half closed interval. For the fourth set notation, if we say x such that x is greater than a but less than or equal to b, in this set notation number a is not included but number b would be included, as we have attached an equality with inequality x less than or equal to b. Its classification is as finite and half open, half closed. As a next set notation, we have x such that x is less than or equal to b. You can see its geometric picture against this, where b number is included and all the numbers which are less than b would be included as well. Its classification is as finite and closed. As next set notation, we have x such that x less than b, where all the numbers less than b are included but number b is not included in fact. Its classification is as finite and open interval. As third last example, we have x such that x is greater than or equal to a, where all the numbers greater than a would be included and number a as well. Its classification is as finite and closed interval. As in second last example, we can consider x such that x is greater than a, where number a is not included but all the numbers greater than a would be included in this interval. Its classification is as finite and open. As a last example, if we consider a simple real line, write it as x such that x is a real number. Its classification would be finite and open and closed as well, where all the numbers on this real line are included. The next topic of today's lecture is inequality. You can see the definition and symbols used for inequality on the screen. Inequality. Inequalities are the signs which make any statement true for different numbers. Some symbols for inequality are less than or equal to, greater than or equal to. Dear students, as we can find out the solution of equalities or equations, so same is the case with inequalities, that we can find out the solution. The definition for the solution of inequalities and an example is on the screen. Solutions of inequality. Solution of inequality in an unknown x is a value for x that makes the inequality a true statement. For example, x is equal to 1 is a solution of inequality x less than 5, but x is equal to 7 is not included in the solution set for this inequality which is less than 5, because in the solution of this inequality or in the solution set of this inequality, all the numbers which are less than 5 would be included. Dear students, now we define the solution set or the definition of solution set before solving some examples of inequalities. You can see the definition on the screen. Solution set. The set of all solutions of an inequality is called basically the solution set of an inequality. As I told you, that set is the combination of different well-defined objects. So, the set of all the solution would make the solution set or the final solution set for inequality. Now, let's solve some examples to explain the solution of inequalities. You can see an example on the screen. If we have to solve 3 plus 7x less than or equal to 2x minus 9. For the solution of this inequality, the given statement is 3 plus 7x less than or equal to 2x minus 9. We have 7x less than or equal to 2x minus 9 minus 3. And then we have to subtract 2x on both sides of the inequality. We have 7x minus 2x less than minus 12 after applying this step. 5x less than or equal to minus 12. For the solution, we just need x. So, by dividing 5 on both sides of the inequality, we have x less than or equal to minus 12 divided by 5. Now, from this solution, we can define our solution set as minus infinity to minus 12 by 5, where this parenthesis denotes that minus infinity is not included or defined, but minus 12 by 5 is included as we have attached a square bracket, which is the notation for closed interval. So, all the numbers which are less than minus 12 by 5 and minus 12 by 5 as well would be included in the solution set of this inequality. Dear students, now let's solve one more example of inequality where two inequalities are included in the statement. You can see that example on the screen. Example, if we have to solve 7 less than or equal to 2 minus 5x less than 9. For the solution of this inequality, by making the simplification, we have x greater than minus 7 by 5 and less than or equal to minus 1. So, the solution set for this inequality is a parenthesis minus 7 by 5 and minus 1 a square bracket, where all the numbers which are greater than minus 7 by 5 are included in the solution set, but minus 7 by 5 is not included, and the solution set lies between minus 7 by 5 to minus 1, where minus 1 is included. Dear students, that was all for today's program. So, let me now briefly explain that what we have studied in today's program. In today's program, we covered the topics like classification of real numbers, basic operations on real numbers, intervals, inequalities, and solution of inequalities. Dear students, hope you have enjoyed today's program, and now you are able to solve inequalities and you can represent intervals geometrically, and you can distinguish between open and closed interval. I will join you in the next program with absolute values and triangle inequalities. Till that time, take care and Allah Hafiz.